Hello, I am one student, and welcome to review video number 2 for quarter 3. So back in quarter 1, we talked about rigid transformations. The rigid meaning that the shape that we are transforming does not change side lengths or angle lengths. So let's look at translation right here. When we translate a shape, we're saying that we're going to take this shape and kind of slide it over to another part of the grid. For reflection, we're actually going to reflect that shape, again without changing its angle lengths or side lengths, about a line of reflection. And that would be this right here. So again, this object or this shape is reflected over, and the vertices or points along the shape will be the same lengths or same measure from that line of reflection. And then we have rotation, where we're actually rotating a certain number of degrees a shape about a specific point. Now, it's a little bit of vocabulary, no worries. Let's do a couple of examples. And on your worksheet or in your pair deck, you're actually going to see something very similar to this. It's going to give you these directions. Describe the transformation that occurred using the template below. And what they mean by that is when you're looking at A, we're going to look at to see if this example A is a translation. And if it is, we're going to use this sentence right here and fill it in. If it's a reflection, we'll be using this sentence right here. And if it's a rotation, we'll be using this sentence right here. So let's take a look at example A and think back to our examples up here. So it looks like, I'm going to say this looks like a translation, and let me tell you why. The shape itself, if you look at point F up here, that seems to be in the same spot. This G seems to be in the same spot, and the Y seems to be in the same spot. So it looks like it's just sliding over. If it was a rotation, I think that F would be like over here somewhere if we're rotating it counterclockwise. Or if it was a reflection, I think that G point would be on the other side. So definitely going to be a translation. So I'm going to use this sentence right here for A. So I'm going to say that figure, and when it's talking about the figure, it's talking about the figure that's actually been translated. So figure F prime, G prime, and Y prime was translated. And it's asking me the units left or right. So it looks like if I just look at this F point right here, it looks like it's going right, 1, 2, 3, 4. So 4 units right. And then how many units down? Well, if I went over 4 units, 1, 2, 3, 4. So here we're going 4 units to the right. And it looks like we're going 1 unit down. And that's it. That's all the information we're going to need. It just shows us that you understand this is a translation and how it translated. So let's look at example B. Example B, not a translation, because notice that D prime and D are in different areas. And when you look at this black shape, this is your original shape, and then this is what's going to be translated. So it looks like my D point actually kind of went this way. So it's definitely, I think, going to be a rotation. And it looks like it's rotating in a certain direction here. So we're going to use this sentence right here. So figure, again, we're looking at the red shape figure. We'll say D prime, Z prime, P prime was rotated. It looks like it's rotated clockwise. Well, actually, it's got the degrees first. I apologize. Rotated a certain number of degrees. It's rotated 90 degrees. How do I know it's 90 degrees? Well, if I take this shape right here and I was to just click it once, it's going to be just going, just looking, if you're looking at this right here, and if it's, this is a 90-degree angle, and if I rotate it just this way, it's going to be another 90-degree angle. So it's rotating at 90 degrees in the clockwise direction about, remember that point of origin, that point of rotation, excuse me. So that point of rotation is going to be your origin, 0, 0. So those are how you would use the translation or the transformation review. You're going to use these sentence frames to help you describe the transformation. All right, let's move on to our next one. The next part of our review is graphing a line. Let's use a different color here. So graph the line below, y equals 1/2 x plus 3. Let's do a little bit of a review. What does that 1/2 mean? The 1/2 is equal to the slope. Another way of saying the slope is going to be 1, sorry, it disappeared on me. It's going to be, we're going to go up 1 and then to the right 2. And then what is this 3 right here? Well, that is our y-intercept. And remember when we did our review yesterday, this was all in that review on lines and linear patterns. So here's our y-intercept. And it says we're going to go up 1 and then over 2. Up 1 and over 2. And there's our line. Hopefully that was clear enough for you guys. Again, just make sure that you have your y-intercept labeled and that you're going whatever that slope is telling you. And the last one is multiplying binomials. And we actually had 2 different ways we can multiply a binomial. We can either use an area model or the distributive property. So I will be modeling both of those for you. So for the area model, I'm going to go ahead and draw out my box here, my area model rectangle. And I have x plus 4, x plus 5. So now for my area model, remember it's at length times width. So I'm multiplying what the length is times the width of all my small boxes. So x times x is x squared. That x times 5 is 5x. That 4 times x is 4x. And then the 4 times the 5 is 20. So my area, when I multiply out these binomials, I will get x squared plus 5x plus 4x plus 20. Or I can combine like terms and I have x squared plus 9x plus 20. Either one of those is acceptable. Same answer. But now what if I want to use distributive property? And I remember that some people really liked the area model. It made more sense to them. And some of you liked the distributive property. And that was taking, I'm going to rewrite our binomial right here. And what I'm doing is I'm multiplying by distributing that x. So I'm multiplying that x times the x. And I get x squared. Then I multiply that same x and distributing it over into this next part times 5, and I get 5x. Do the same with the 4x, and lastly, that 4 times 5, which is 20. And again, I can do the same thing here. I can combine like terms, and I get x squared plus 9x plus 20. When you're doing these problems, it says multiply the diagonal using the either area model or distribute properties. So it's up to you. It is student's choice for this. I hope this was helpful review. I hope this jogged a few of your memories. And if you have any questions, feel free to reach out to us. Otherwise, we'll see you in the next video.